For Aiden, we are at the end of the chapter for geometry. I gave everybody a note card, and this is the stuff we're going to write down on the note card. So we have right triangles, we have non-right triangles. This is like one part of the note card, and then we're going to do this stuff on the other side of the note card. So put those headings down. Ready? A right triangle looks like maybe this-ish. I don't know. There's my right triangle. Okay? All right, let's talk about stuff that we can use to solve things in a right triangle. Like if we're talking sides of a right triangle, we can use the Pythagorean theorem. A squared plus b squared equals c squared. I cannot do that on a non-right triangle, but I can for a right triangle. So we can do that. Okay? Talking about sides. Cool. Now, what about angles? Like what if I say like this side is 2, this side is 7, solve for this angle right here. How do I do that? I use SOHCAHTOA, right? So we're going to write that down. SOHCAHTOA. Do you want to actually go through and solve that thing and figure out what that angle is or no?
I don't care.
You don't care?
No. I don't care.
Which trig function would you use to solve that angle?
Adjacent. So, TOA.
Opposite adjacent. This guy's opposite, this guy's adjacent, so we'd use tangent, right?
Yep.
Regular tangent or inverse tangent?
Normal. Inverse. One of the two.
This is my x, right?
Why would you use inverse?
So we have tangent. Tangent of what?
Oh, x. So
X
inverse.
equals opposite over adjacent, so 7 over 2, right? How do I get the x out of there?
Negative.
I have to do inverse. Anytime you're solving for an angle, no matter whether it's a right triangle or not a right triangle, you're going to use inverse, sine, inverse cosine, inverse tangent, whatever, if you're solving for an angle,
I'm curious.
whatever that is.
74.1.
74 degrees is what he is, if you want to write that down. You don't have to, but anytime you're solving for an angle, you have to use the inverse,
It's a big angle.
right? 74 degrees, yeah. The other one would be, what, 16 degrees? 74 and 16? Yeah, if that's 2 and that's 7, right? Yeah, not too bad. Right triangles, kind of boring. Those are the only two things that we do with them, okay? Non-right triangles, I don't know how I want to draw this. I'm going to draw a house.
Just try like. Oh, I'm just.
I'm going to draw the roof on a house. This is going to be an obtuse triangle, okay? Whatever. Non-right triangle, doesn't matter what it looks like, just not a right triangle. I have two options for non-right triangles, and they are the law of sines and the law of cosines. And these two formulas help me find angles and sides both. Doesn't matter, right? Kind of like SOHCAHTOA you could use to find angles or sides. Doesn't matter, right? What's the law of sines? Sine of, let's say, sine A over little a equals sine B over little b, right? And it could be C also. It doesn't matter what they're named, but that's the proportion that you set up. Sine A over A equals sine B over B. Or sine C over C. Doesn't matter. Law of cosines. Do you have it memorized? Do you remember what it is?
C squared equals A squared plus B squared minus 2AB cosine blank. Or
Cosine of capital C. Yep. Okay. Yeah, that's what he is. Okay, how do you know when you use the law of cosines?
Three sides, one angle.
3 sides, 1 angle. And one of those 4 things you're solving for, right? There's 4 pieces of information. You might be solving for the angle, or you might be solving for one of the 3 sides, right? 3 sides, 1 angle, okay? For the law of sines, it's 2 sides and 2 angles that are involved in your proportion thing. Okay? One of those 4 things you're solving for. So it just depends on what you're given to which one you use. And we're going to do that here in a second. Okay? Let's also go down here. I don't know if you have room or if you wrote a line. But I'm going to talk area. Area of a triangle. Area of a triangle is 1/2 base times height, right? But if it's not a right triangle or not a nice triangle, the area is 1/2 BC sine of A.
This is for which one?
This is for non-right or right. It doesn't matter. Really, if it is a right triangle, like if I was trying to find the area of this guy,
There's no point.
I would just, there's no, you could use this formula if you wanted to, right? But I would just do 1/2 of 2 times 7, because I have a base and a height. But you could certainly use the formula if you wanted to. Just like, actually, you could use the law of sines to solve this guy, or the law of cosines to solve this guy. I don't know why you would, because SOHCAHTOA is faster. But you could certainly do that. You just can't go the other direction. Like I can't use these two things to solve non-right triangles. That's not going to work, okay? So area is 1/2 BC sine of A. So it doesn't matter which angle you're given. Maybe it's actually angle C. But in your triangle, whatever your angle is, it has to be the two sides that are right next to him, right? That's your B and your C. Your B and your C are the two sides that are right next to your angle, that are touching your angle, right? Okay, good? All right, on the back side or wherever you want to put this, we got to have a 45, 45, 90, and a 30, 60, 90. We're going to write down the sides of this guy, what the ratios are. And some of you guys know these already or have them memorized. I would memorize these for the ACT. Juniors, 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 juniors. Okay, what are the sides of a 45, 45, 90?
1, 1, 2, or 1 square root of 2.
1, 1, and the square root of 2, or 1 square roots of 2, right? So if this bottom side is 5, this side would be 5, this guy would be 5 square roots of 2. What if, like, this side is, like, 12?
Then it's like
How do I get back to this side?
12 square roots of 2. Or no, wait, that's 12, so
If this side is 12,
12 over square root.
it'd be 12 divided by the square root of 2. Instead of adding the square root, like multiplying by the square root of 2, you would divide by the square root of 2. That's what they would be. You don't have to write those down if you don't want to, but okay.
We did a thing where you like, we had it down. It was like how you go from each side to each side.
Yep. So on this guy, if you're going from here to here, you're going to multiply by the square root of 2. If you're going from here to here, you're going to divide by the square root of 2. Yeah? And I guess these two should be the same, right? So multiplying by the square root of 2 or dividing by the square root of 2, that's all you're doing. Okay. Are we ready to go over?
Yeah.
Yeah. 30, 60, 90, what are his sides labeled? 1 is the bottom. 2 is the
Oh, no, hypotenuse.
2 is the hypotenuse, because 2 is bigger than the square root of 3, which is the tall side. Okay, 1, 2, square root of 3. All right, so let's talk about going from one to the other. I just double it. So if this is 7, that's 14. What if they give me this guy, though? How do I go from here to here? I just divide by 2. That should make sense, right? Okay. If I'm going from here to here, times the square root of 3. So if it's 5, that becomes 5 square root of 3. What happens if I'm starting from this side and I'm going back to this side?
Divide.
I'm dividing by the square root of 3. That's all you're doing. Multiply by the square root of 3, divide by the square root of 3. I never, ever, ever, ever go from here to here. Right? I always go back to the one side and then convert it to the other two sides, right? So I don't ever go from the 2 to the square root of 3 side in the same time, whatever. Okay? Is that kind of confusing stuff-ish? Okay, good. All right, beautiful. Okay, all right. I'm going to give you one of these. This is the review. There are like 25 questions on this review, but this morning we worked backwards and we just did 20 through 23 if you want to do that, because that is law of sines and law of cosines, and that's fresh in our brains. Sound good? Should we do that? Okay, so let's do that. Yeah, let me give you that paper real quick.
No issue.
Okay, do you want to do like 1, 2 together and 2 on your own? Or you want to try all of them on your own? You tell me. This is review, so this is for you.
2 on our
I'll
own.
do whatever you need me to do.
2 on our own, 2 together.
2 together, 2 on your own. Okay, before we do all, like, whatever together and whatever on our own, let's start these. Each one of these is solve the triangle. These are the pain in the butt ones, right? And that's why this is all the further we got this morning, because they do take a while. So on each one of these, for every single one, do an ABC, ABC. Okay, get him set up and get him ready to go, and then we will fill in the things that we have and the things that we need. ABC, ABC. I'm gonna go over here. A, B, C. I'll quit talking. Are you guys filling in the stuff that you have and you need already?
Mm-hmm.
Yeah? Okay. I'll do that at the same time. And then before we start, we'll talk strategy. Mm-hmm. 23 is the hardest it gets. 22 is kind of nice. Did you get them all written down? Then let's talk strategy. Let's figure out on each one where we're going to start. All right, number 20. If we're on number 20, given the information we have, so I have all my stuff right there. I have the 3 pieces of information that they give me, because they always have to give you 3 things. Can you use the law of sines, or do you have to use the law of cosines? How do you know?
Because you have an angle on the side.
Yeah, you can use the law of sines if I know one set, right? Like I have a pair of 2 things that go together, like A and A, I know. B and B, I know. C and C, I know. Because I can set this up as sine of 72 over 8, right? So I can start here with the law of sines. I don't even have to do cosines, right? Let's talk 22. Strategy on 22. Sines or cosines?
No sign.
Can I do law of sines?
It'd have to be.
Do I know one full set?
No.
No. So I have to do the law of cosines, right? Which one are you going to find first when you do the law of cosines? Cosines is 3 sides, 1 angle.
C.
3 sides, 1 angle.
C.
3 sides, 1 angle. So I have to solve for C first. Little c first. That's what cosines. Okay. Now, let's go to this one. Sines or cosines? 23. We have to do cosines, right? And solve for an angle first. So that one's going to be a huge pain in the butt. Let's talk 21, though. This was kind of tricky.
It would be law of sines, because you could just subtract from what you.
Yeah. So looking at this right now, I don't have a set of anything, but also the law of cosines, I have to have 3 sides, 1 angle. But that's not what I have, right? So what I can do is these 2 make 132, and if I subtract from 180, what's that middle angle going to be?
48.
48. Now can I use the law of sines? You betcha. I always like to use the law of sines if I can, because sines is quicker for me than cosines. Yeah? So now we have a strategy. The top 2 we're starting with the law of sines, the bottom 2 we're doing cosines. Okay, would you like to do 20 or 21 together?
20.
20? Okay, all right. So I have one set. I have sine of, oh, which one are you going to solve for first, by the way?
C.
C, big C, right? We have to do it in that order. So I have sine of what? 72 over 8 equals sine of x or c or whatever you want to call it over 6. All right, we're going to cross multiply, divide by 8, and then we have to inverse sine.
I got 45.
You got 45 degrees?
Well, actually 46.
Is it 46? 46. I would strongly encourage you when you type this into your calculator to use the answer button as often as you can, because if you retype any numbers, it will make your number rounded and not quite as accurate. So 46 degrees. Okay, now what? Those three add up to be?
Subtract
62.
from 180.
B is 62. Yep, so subtract from 180. Now what?
Do another.
Do another law of sines. Okay, now, hold on. When we do law of sines, I can use these two to solve for B, right? And I can set it up like this. Or I can use this one and this one and this one and this one. Which one are you gonna use?
The ones that we were originally.
The ones that you were originally given, right? We came up with 46, but 46 was rounded, true? So I want to keep from using him if I can. So I'm gonna go back to the original, the 72 and the 8 that I was given, right? Confusion about that? Okay, so sine 72, I already have it written up here, so if you want to just change your values. Sine 72 over 8 is sine of x over, no, sine 62 over x. This guy divided by sine 72. Question. Do I have to take the inverse sine? Can we do this one? Do we have to? Eight sine 62 divided by sine 72. Do we have to take the inverse sine? We're solving for x. X isn't trapped inside of a sine, so we don't have to do the inverse sine. We just multiply and divide by sine 72. What'd you get? Are we stuck? Do I need to backtrack?
I'm just. 7.4.
It sounds reasonable. Yeah. Yeah. Now, one more real quick check before you stop and move on to the next problem. Biggest angle, biggest side. Smallest angle, smallest side. They're opposite each other. Cool. Make sure you check that. Okay? Because maybe you did something wrong. We were solving for this guy. Could we have done the Pythagorean theorem and used the other two sides, right, to solve him? Could we have? How's come?
Not a right
He's not a right triangle. Okay. So, all right. Do you want time to do 21? And then I'll do it too and you can check? Okay. Maybe? I gotta take this down, yeah. Okay, did you get that for 21? 6.8 and 15.4, maybe? Yeah? Opposites are correct. Big and big, small and small. Yeah? Okay, do we want to do 22 or 23 together? 22 together? 23 is the hard one.
Oh, yeah. 20.
I don't know.
Yeah.
We can do 22 together, but I'm just saying.
23 and I said 20.
How do I know 23 is harder?
Because you have two sides and you have no angles. So you
And you have no angles. Solving for angles is crappy. Solving for angles sucks.
Can you go
It's
to
so
20
bad.
real quick?
20? Okay, and there's 21.
I was looking at 23 as a
48, 7, 6, 28, 12.
Okay, no.
Okay, 23. Do you want to solve for ABC first?
Oh.
Which one?
C.
C.
C
C?
will just make it easy.
Sure, C just makes the formula go right. Okay, so C squared equals A squared plus, you don't have to write this down because you already have this. AB cosine capital C. Okay, so capital C is going to be like my X. Lowercase c has to be 16. 22, 20, 2, 22, 20. Ah. Okay, I'm pretty sure we had this problem as a homework problem one time. Like these exact numbers. 16 is 256, 22 is 484, 20 is 400. If I add those together, that's 884.
Yeah, I think we had this as
Minus 40 times 22 is 880, I think. Cosine x. Okay. Then subtract 884. I don't know what that is.
Minus 620.
Okay. Then divide by 880. If you're stuck and confused and you're like, how did you get that? You stop me and I'll backtrack.
0.7136.
Okay, and then inverse cosine. Use the answer if you can.
Should be 44.5.
44.5. Did you round to 5?
So it would just be 44.
So it'd just be 44 degrees? Okay. 44 degrees is C. Okay, now can we use signs?
Yes.
Yeah, which one do you want to find? Now, B, or we're just working backwards? So we've got this guy. Sine 44 over 16 equals, whoop,
Sine X.
sine B or sine X, whatever you want to call it, over 20. Okay, cross multiply, divide, inverse sine. That's what B is. If I'm going too fast.
60.3, yeah.
What?
60.3.
So 60 degrees,
Or, yeah. And then
76.
76.
Was that too fast? That was okay? Okay, that was 23. I'll leave him there. You do 22, and I'll check in a second. This one's nice. Somebody tell me if that's right. Is that right?
Yep.
Yeah, okay. All right, I don't trust this calculator, so. Did you go B or A? B? Okay, good. Do you want to stop or do more? Stop? Okay. All right, we'll stop. I gotta stop recording.